Okay guys, and welcome back to my video series on vector algebra. I'm George Bomasmith. Now in this video we are going to be looking at how we can represent vectors in terms of the unit vector. Okay, now if you guys recall, in the previous video we looked at different types of vectors, and then we also considered unit vector, where we said for unit vector there is a cool way. These three types of unit vectors we have the one that we use to represent a unit vector in the x-axis. We have that for unit vector in the y-axis. We also have that for unit vector in the z-axis. And then we said the unit vector in the x-axis can be symbolized. In the x-axis we have I, in the y-axis we have j, and then the z-axis that we have k. So this is the y-axis, and then this is the z-axis, we have k. Okay, so in this video we are going to see how we can express every vector in terms of the unit vector. Okay, and also what are the components of vectors. So you have a vector, let's say you have a vector A, and usually if this vector is having three components, if it's a vector in terms of three tuples, then that's basically what we call them. Then you have a vector that will look like this. So these things are called a component. This is the x components, this is the y component, this is the z component. Those are what you call them, components. So this is a component in the x direction, component in the y direction, and a component in the z direction. Okay, now when you have these vectors, you can basically represent them in another form. Now what's the other form you can represent them? You want to represent them in terms of the unit vector. What you're going to get is something like this. So we pick the x component, multiply it with I, pick the y component, multiply it with j, pick the z component, multiply it with k, and that becomes the unit vector representation of this vector. I don't know if you get that. Now let's see an example. You have something like a, and a is equal to 4 minus 5 and 7. So this is the x component, the x component is 4, the y component is minus 5, the z component is 7. Now if you want to express in terms of the unit vector, you have 4i minus 5j plus 7k. So if you ask for the x component, please, the x component is not 4i, it is 4. The y component is not minus 5j, it is minus 5. And the z component is not 7k, it is 7. These are the components. So let's see. Let's say I have another example. I have b, and b is equal to, let's say I have 7, I have 0, and then I have 3. For the fact that I have b to be in this form, I can express this in terms of the unit vector. And if I'm expressing in terms of unit vector, I'm going to have 7i, okay, then I have plus 0j, and you can understand that plus 0j can be removed, and then I have plus 3k. So here the x component is 7, the y component is 0, the z component is 3. So I can go ahead and take away 0, then that's where you're going to see something that looks somehow like this, just 7i. Okay, you're going to see 7i and then plus 3k. Wow, I can't wait to get a good tab, a good writing material to be doing this. Okay, so that's what we have for the vector representation of the unit vector representation of a vector. Is as simple as this, and this is the form we are going to be working with. Okay, so even if we see it in terms of the Cartesian coordinate, because this other representation is called the Cartesian coordinate, even if we see it in terms of the Cartesian coordinate, in most cases, almost all of the cases, we are going to convert them to the unit vector representation. That's what we are going to be making it of. Okay, so if you have any question, go ahead guys to ask, put them in the comment section below. You can reach out to me and ask these questions, and I'll see you guys in the next video where we're going to be talking about the magnitude of a vector. I'll see you guys then. Bye bye.